Hello, hello. Welcome to today's webinar. We're going to talk about where GitHub Actions fits into a DevOps architecture. I am really excited to be here with you today. My name is Jeffrey Palermo. I'm the chief architect at ClearMeasure, and we're a software architecture company that helps make development teams self-sufficient, moving fast, delivering quality, and running their software systems with confidence. And so my goal here is to guide you in how to think about this up and coming DevOps product and where it fits in with the DevOps architecture. I want to stress DevOps architecture. DevOps is a large process to get a really good outcome of continuous flow and consistent quality. And it's not just one technique, it's not just one product. And so there's a lot of people that are looking at GitHub Actions, and I want to talk about what it is and how it fits in, where it fits in, and what are the things that you need to have. And there's no just one-stop shop. There's a mix of things that you put together. Now, if you're tuning into this, then that means that you probably want to get more done. You probably want to move faster. You want to produce higher quality so you can deliver for you and your team. And I know from experience that not just adopting any product, but if you map out your whole software delivery process and then automate it, then you'll deliver more, and you'll absolutely love doing it. And so we're going to talk about that today. We're going to probably go. I'm going to target for a 30-minute webinar to talk about this topic, and then deliver it with efficiency. So let's kind of get right into our agenda. We're going to talk about the overall pipeline, just so we can frame the discussion, the DevOps challenge, the pipeline structure, and then what GitHub has implemented in the DevOps space in addition to distributed source control, and what you can take advantage of. Logistically, there is a Q&A window that you can use to submit a question, and I'll try to answer the questions in line during the presentation. But my commitment to you is, if I don't get to those questions, I won't end the webinar until I've answered every question. All right. So a few things, a few resources. I want to give you something of value and help you get automated. I released my latest book just at the end of last year, and it's called .NET DevOps for Azure. All of the examples do use Azure pipelines. We have a discussion with some other products like Octopus Deploy, Redgate SQL Change Automation. There's a lot of Azure in there. Of course, .NET and Azure are the main two platforms. But yeah, I want you to have this, so it's a free resource. If you just email me directly or request it in the chat, my webinar assistant will be able to take that request, and my email address is right here on the screen. Whether it's asking for a free book or anything else, or just asking a question about all this stuff, please do so. Please do so. I love all the people that I've met and helped. Over my career, at ClearMeasure, we've helped over 100,000 professionals in over more than 40 countries be better at software. And this book is just one of those resources, hopefully giving .NET development teams the answer to the pit of success, and the guidance to do it in the right way, so that you don't have to bang your head against the computer for weeks on end to get things done. You can pick the way that actually works and get down the road. And so read the book. And step 2 is understand the 7 key stages of a DevOps pipeline, which will be in the book, and then launch your own .NET pipeline for your project. You can use our public project in the book as a model. We go over it in depth, and it's available online. If you do this, you're going to have a fully automated DevOps pipeline using Azure that'll enable you to move faster and with higher quality. Now, if you want me to give you the cliff notes to this talk, everybody's asking, should I implement GitHub Actions? Well, the answer is if you already have an automated DevOps pipeline, keep using what you're using. GitHub Actions has part of it implemented, but if you already have an automated DevOps pipeline, it doesn't have anything implemented right now that's going to say, oh, this is so much better than Azure pipelines. However, if you don't have anything automated, then it has pretty good triggered build support. And it also, GitHub Actions, the reason they don't call it GitHub pipelines, in my opinion, I don't have inside knowledge about the naming, obviously, but the reason they probably don't call it GitHub pipelines is because it really can trigger off of anything. It is a way, if you've looked at, I look at Microsoft 365 or the Power Apps and Flow, and some of the CRM products have different actions that you can trigger, or IFFT or Zapier has all these things that trigger and do things. That's what GitHub Actions, it makes me think of, because yes, you can run a build with GitHub Actions, but you can also trigger some type of notification and integration on a pull request, or you can push things into Slack. It's kind of a general purpose triggering mechanism. So that's the Cliff Notes. If you're wondering, hey, should I be using this instead of something else? The answer, if you've already got something else, no. So another resource that you might be interested in is the podcast that I host, Azure DevOps Podcast. You can find it in any of the podcast directories, and take a look at that. All right. So to answer the question where GitHub Actions fits in with your DevOps architecture, we need to at least just level set on the 7 key elements of a DevOps environment. And I'm not going to go through all. I have other webinars that go more in detail of these. We did a 7-part webinar series diving deep into each of these 7 that you can go on empower.clearmeasure.com and look at those archives. But in order to succeed with your DevOps environment, you need to have the 4 different design decisions modeled out on your Kanban board in your pre-code design process. You need to have your version control structure a particular way so that you have the right granularity in the structure of your Git repositories. You need to have both types of builds implemented, private builds and integration builds. You need to have full system testing integrated in with your continuous integration process. Another probably a bombshell for some of you that haven't heard it before. If you aren't verifying that your application can still deploy and still start up, then you're not finished implementing continuous integration. You don't know that the change that you just integrated didn't completely destabilize the code base. And we all know that a build can work, a unit test can work, integration test can work, but the application might still be broken and not deployable. And you don't want to give a new build to somebody, say, oh, it's ready, it's go test, we just deployed, and it quote deployed successfully. But if it doesn't start up, if it can't do anything, we just totally destabilize the code base. And continuous integration is meant to answer that question: do I still have a stable code base? And so you're not done implementing continuous integration until you've done at least one deployment and started that application up, and run a couple tests, at least a few full system tests to make sure it still works. And we're not going to go into all 7 of these, but I do want to talk about the imagery of a pipeline. And if you've come to some other webinars, you probably heard me talk about this. The imagery in a pipeline is one of water. Water is the perfect imagery for a DevOps pipeline. You want smooth flow. You want consistent water pressure at the tap when you turn on. And you also want clean water. You don't want impurities. So let's correlate that with software. We want a smooth flow of features, of changes through. We want a consistent water pressure. Just like if you turn on your faucet and there's nothing coming through, then that doesn't help you. But at the same time, if you turn on your faucet and it's like a fire hose just spraying everywhere, that doesn't help either. Trying to push a tidal wave of water through that pipeline, you want a consistent flow. Scrum teams learn that, man, if they try to do DevOps, it's kind of weird doing the sprint planning and the retrospective and 2 weeks of go. Okay, let's stop. Let's try to stabilize and deploy everything. And so mature Scrum teams end up falling into a Kanban style of work because that is very compatible with the automated DevOps methodology, where you want a smooth flow. In other words, every day we want to be doing deployments. And so we have to have stable builds every day. And so we need a constant water pressure, consistent flow. We need to decompose our work into implementable chunks. Scrum has estimations. And when you go to DevOps, it's a lot less about estimating work, and it's a lot more about just decomposing the implementation of the work and then counting how many things you have to do. And if we make sure that we decompose the work into implementable chunks that are doable within about a day, then we can just count up how many things we have in the development column on our Kanban board. And that's enough to do project management and do forecasts. In the technical design column of your Kanban board ahead of development, you want to be taking those larger features and decomposing them into implementable chunks before you give them to your developers. And that's a big responsibility of whoever the development lead is, whether it's formally called a lead architect or if the title is lead engineer. There has to be that role that's working ahead of the team, that's translating from the business features, making the technical decisions, and decomposing that into implementable chunks. We also want quality of this water. And so in the DevOps world, that means that we can't just put a whole bunch of filters and checks right there at the end of the faucet, at the end of the pipeline, and expect to catch all the impurities. We're just going to slow everything down, and we're not going to have any water pressure. We need to have a filter and a water treatment everywhere up and down that pipeline. And so on the automation side, we need filters, tests, validation techniques every step of the way of our DevOps pipeline. And so that's the corollary. Now, this is a highly shrunken technical blueprint for the structure and flow of a pipeline. And we see some representative products here. We have Azure DevOps Services. We have Octopus Deploy. We have Redgate for the SQL change management. We're not even listing the telemetry products. There's always a big mix of products, but that's not important. The architecture and the flow is important. And so this has outlined every step of the way for a DevOps pipeline for a particular application. The bare bones scenarios that you need are in the box on the bottom left. These are the tickets to the game. You have to have these. And then every application, depending on its architecture, is going to build on these and add additional things to help with smooth flow and throughput, and help to catch problems, which is your quality controls. If you're in an audited space, they're really interested in quality controls, because those keep problems from happening. And DevOps gives you a way to formalize controls, auditable controls, into your environment. I want to give you this. It's actually this is the top third of a larger poster. And I want to, if you don't already have it, I want to give you the high resolution copy of this architectural poster. You can print it out large scale, a plotter or a print shop, or just keep it around. But this is our architecture for DevOps. And so what we're going to explore today is what parts GitHub Actions can slot in with, and what parts you need to think of mix of products and have them interfacing. So we're really going to try to shed light on where GitHub Actions can fit in to your overall DevOps architecture. But if you don't have this poster, send me an email, request it in the chat, and I'd be happy. I want every single one of you to have this high resolution poster. All right, so version control. Now, GitHub Actions is part of GitHub. It provides source control. Great, that's kind of an obvious, right? But you need one Git repository per versioned application. That's super important. If you decompose a software system into different applications, each application needs to be in its own Git repository. So here's kind of the rules of thumb when thinking about how to segment your version control structure. All right, and GitHub works great for this, and we use it a ton. I think the two popular ones right on the Microsoft side now are Azure repos and GitHub for Git repositories. So it can definitely do a great job being your repository. You'll want to be on the enterprise plan in order to get single sign-on with your Microsoft account so that you can integrate those. If you're not on the enterprise plan, you can use individual GitHub accounts, but a lot of organizations want to have the Microsoft Work account be what's used in order to authenticate. And the Git repository, even if you're using Azure, and I think most of you probably are using Azure pipelines for your builds, you can have your source control in GitHub, and then Azure pipelines integrates really well. So GitHub works great for version control system. All right, now builds. Let's talk about builds. The private build has no bearing on GitHub Actions or Azure pipelines or anything. Your private build runs on a local developer workstation, and you need a private build script. If you only have the Visual Studio solution and building is nothing more than compiling locally, you do not have a private build. Go back and read the 2007 book titled Continuous Integration from Addison Wesley publishers, where continuous integration is the whole book on it and the different stages. And the two main types of builds are the private build and the integration build. And so you need a private build script for every application, which means that you should be able to clone a Git repository, run the private build script, and have it provision and set up everything about your local development environment, and run through, definitely do a compilation, run the application's unit tests, component level integration tests. It's likely that the integration test will depend on some type of SQL Server database schema. So ahead of that, you'll need to use your database schema migration tool and the SQL scripts that are in your Git repository, and create that local SQL Server schema so that the integration test can run and pump some test data in, do some routines, check some things, and then you're done. Now the integration build adds on to that, and we want static code analysis to be in there. We also want to publish the test results so that we can browse them and see them and trend how long they take over time. And we also want to package the set of release candidates so that the different deployable pieces of the application have deployable packages that are archived properly. For example, if you have a web application and a offline job of some sort and a SQL database, well, that you have one application, one Git repository, your release candidate consists of 3 deployable packages, 3 NuGet packages. Azure Artifacts is the premier package management product. And NuGet is your friend from a file format. Zip files can work just fine. And so let me talk about GitHub's offerings here. GitHub Actions do support triggered builds. So again, the private build is your own developer workstation. It has no bearing on whatever build server you're using. GitHub Actions can function as the trigger for your integration build. GitHub Actions has text YAML support only. I'll show you the screens later. And so you'll have to be well-versed on the YAML format for its builds. And it doesn't have a designer, and it doesn't have a test reporting dashboard just yet. And so it's not a fully featured build server. And that's probably the big thing just to know, that GitHub Actions has a lot of capabilities, but it is currently not a fully featured build server. And so to call GitHub Actions, we use GitHub Actions for our build server, it's not really the right way to think about it. If you for your build server, you're going to want a fully featured build server capability. Azure Pipelines has that, where it tracks test cases. It has line graphs around this, and all kinds of different things, and captures artifacts of the builds and all that stuff. You can do a lot with GitHub Actions, but again, it's more of that flow style triggered routine. You can use it to run builds, but you can use it for all kinds of stuff. And I'll show you the screens later on. All right. Now, for deployment, you want your integration build at the end of it to package up the release candidates, store it in a package manager. GitHub does have packaging support. And so it is possible to use GitHub's package support. Now in the whole Microsoft ecosystem, Azure Artifacts is still your best option, but it has, it acquired a product last year. It's been integrating that, and it's supporting packages. And I expect that support will get better. But we want to have one release candidate, and we want to deploy it to any downstream environment. You need a minimum of 3 environments in your pipeline, because there's 3 distinct environment types in a DevOps pipeline, and you need one of each. Production, you need at least one. A manual test environment, I call UAT, you need at least one manual test environment. Most teams have a lot of manual test environments. They have dev, they have test, QA, UAT, staging. Those are all manual test environments. But then we need the TDD environment. That is the test automation environment. That's what's missing in a lot of pipelines that we look at. And that is the environment that enables you to have a complete continuous integration process, that enables you to, once the integration build finishes, to automatically trigger a deployment to an actual environment, start up the application, run a few tests, make sure that the application actually starts up and you didn't totally break everything, and then it's done and we totally trash the environment. So if you're in the cloud, you provision that environment from scratch, you deploy to it, run a couple tests, make sure you're good, and you destroy the environment. If you're on VMs, you can multiplex that environment, because if you're doing web applications on IIS, Windows services, and SQL Server, just by tokenizing, putting in the build number into the Windows service name, into the IIS web application name and application pool, and putting it into the SQL database name, you can multiplex a lot of deployments on the same server. Again, we're not doing it. There's not any high load. I mean, there's very little load on this, so we don't need much processing power. And IIS can support ton of web applications, Windows services. If they all have a unique name, Windows is happy. Same thing with SQL Server. So you can have one Windows server and get a lot of mileage supporting any number of parallel TDD environments, even when you have this configured on feature branches, so that changes made on a feature branch have the benefit of having the answer of, hey, does this thing still deploy and start up, or did I just totally break it? So that needs to be in your architecture. From GitHub Actions, I would say it is possible to do the deployments and manage your deployments. However, you're on your own from a scripting perspective. The library of available actions is building up, and there are support being added more and more for Azure and AWS and all this stuff, but it's in progress. If you're looking to adopt something that's going to let you kind of get implemented and get down the road, then for deployments, you still have 2 viable choices right now where you're not going to have to just do a ton of scripting and integration on your own. And those are Octopus Deploy and Azure Pipelines, the release management part of Azure Pipelines. By the way, if you're in Azure Pipelines right now, implementing the YAML support, use the YAML for the integration build, but you're gonna, if you haven't already implemented it, the YAML support is not fully featured, fully fleshed out for releases. So while it may be possible to do deployments using YAML, you're going to do a lot of your own custom scripting. So the step-based designer based deployments using the release manager is still going to be your best bet. And then Octopus Deploy, it just continues to be phenomenal. It has integrations and built-in step templates for absolutely everything under the sun, and they even have Kubernetes, where you don't even have to know what Kubernetes is anymore. You just kind of go to Octopus and say, hey, just do it. And it's like, okay, I'll do it. And that's really the advantage of those commercial products, is you just get down the road so much faster than having to do so much of this yourself. And so if you've got somebody on your team that's been working for weeks trying to get stuff working, stop. You need a higher order product to get you down the road. So I would say on the deployment side, it's a wait and see for me on GitHub Actions to see what their support is going to be. On defect removal, the pull request flow is important, because we want to be able to a deployment and then come back and do a pull request. And so GitHub has fantastic pull request support. They always have, actually. It has nothing to do with GitHub Actions. So pull request runs really well. All right, now let me give you a kind of compare and contrast with how Azure Pipelines looks and how GitHub Actions looks. Your pipeline is going to look like this in Azure Pipelines. If you have one of each environment type, we have the TDD environment. That's our one test automation environment. UAT would be our one manual test environment in production. This is as simple as it gets. You're never going to be shorter than this. And it's a four-step process. Your integration build, you push the artifacts into Azure Artifacts so that they're available. You deploy the TDD environment, and you see the 100% test automation. And then we deploy to the UAT environment, and then deploy to prod with approvals. Oh, by the way, with approval steps, that's another reason why you might go with GitHub Enterprise in order to be able to log in with your Microsoft account, because your approver, maybe you want your approver to be a stakeholder and have a stakeholder account, and GitHub needs to flesh out what that workflow is going to be. So if I go, okay, so this is Azure Pipelines deployments. The pattern is really simple in Azure Pipelines. You get a package, you configure an environment, you do your deployment. You get a package, you configure an environment, you do your deployment. And then even for the test automation, you get a package, which is the test suite, you configure the test suite environment, and then you execute it. So this is the deployment, what the deployment looks like for a TDD environment for an application that has a web application and a SQL Server database. Again, you want to deploy those together. If you're deploying just a web application and not a database, you're just getting started. You got to put that database in. Any application, every application relies on operating on some type of data, even if it's not SQL Server, even if it's just a directory structure of files. Every application has to operate on data. So every application needs to own some data, okay? Now, of course, we pull in data from other sources, and we call via an API mechanism, some type of transport and get data. We borrow the data. We get a read-only copy of data we don't own. That's perfectly fine. But every application needs to own its own transactional data. Otherwise, it's architecturally, it's just a process that's a part of another application. That's an architectural discussion for another time, because databases that have been around a long time and have 15 applications that all have the connection string to it, we have to sort out that architecture so that we can do our DevOps environments. We do a lot of that, helping to sort out the environments and what the legacy architectures actually are, so that we can design the proper DevOps environment for those. Okay, so on the GitHub Actions front, well, this is what it looks like in pipelines. And when you run it, you have all of these screens to keep track of your test runs and keep track of artifacts. Like this is running Selenium tests against a fully deployed instance of the application, and it's doing screenshots of a screen that has text boxes and buttons, and Selenium is typing in text boxes and clicking buttons, and it's capturing not only that the test ran, but the timings and attachments of those, and has a full capture of the test results. That's important. GitHub Actions doesn't have that right now, and so in order to support test suites, you're going to need to be in Azure Pipelines and kind of wait and see what GitHub Actions comes up with for running .NET tests. So this is GitHub now. Let's look at what it is, what it has, and this is a repository. You'll notice the .github/workflows. When you create a GitHub Actions, it's going to store those YML files in a new folder in your repository called .github/workflows. And what that means is that the actions are going to be versioned with the application, because it's in the same Git repository. And when you modify any of these YML files, it's going to trigger a build, because guess what? You were modifying something in the repository, unless you do a filter and you don't do it. Okay. All right. And so it's stored there. Let's kind of dive in. I've implemented here just for structure is ultimately what we need to have. we need to have a 4-stage pipeline, which is the simplest you're ever going to get. The integration build is first, then we deploy to the TDD environment, then we deploy to UAT environment, and then we deploy to prod. Okay, 4-step process, and we need to chain those together. It's your call how many YML files to have, but I like having 4 different YML files, 4 different actions. Each YML file is a GitHub action. Okay, and I like having 4 of them so that I can see these individual ones, and because it is a separate action. There's a lot of integration builds that'll take place that if they fail are never going to cause a deployment to the TDD environment. And if they deploy at TDD, they're never going to cause the deployment to the UAT environment, that kind of thing. Okay. All right. And there is a question. I'm just showing you what, say, the integration build. By the way, I am looking forward to some enhancements in GitHub Actions, and I am not able to do everything that I like to do in an integration build so far with GitHub Actions. I do everything that I like to do in our Onion DevOps template that I wrote about in the .NET DevOps for Azure book, and is in our public Onion DevOps architecture project. And so I can do everything that I want to do in Azure Pipelines, and I can do some of what I want to do in GitHub Actions so far. It's new. It's new. I just want to give you the status of it. There's a question of, I keep seeing my GitHub action fail when another person creates a PR. Any idea why that might be? Well, I have an idea on why it might be triggered. Not sure why it would fail, but when you create an action from the .NET template, it's going to give you 2 triggers by default, and you can see those triggers here. It's the on section. So this means that we're going to trigger on commits pushed into the master branch, and this is a branch filter here, or on pull requests that affect master. So that's the trigger. Okay. Now, GitHub Actions doesn't have as many diagnostic tools yet as we do see in Azure Pipelines, but again, they're working on it. It'll come. But you see this integration build. I want to highlight the key steps. So right now we have one job. We're running on Windows. We can run on Ubuntu. We can run on Mac OS. Under the covers, and I'll show you in a little bit, when we look at the log output, it suspiciously looks like the log output of Azure Pipelines. And the fact that you can run on a Mac suggests to me that they're likely using some of the same architecture as Azure Pipelines, rather than GitHub building their own Mac OS data center. So with GitHub being owned by Microsoft, I would expect them to share some of the capabilities to be able to target Ubuntu and Mac OS under the covers. All right, but for an integration build, if you're using .NET Core, you do want to structure your .NET Restore as a separate action so that you don't have to do it 3 times over. If you don't specify Restore, if you just do a .NET build and have no command line switches, it's going to do an implicit NuGet restore. If you do a .NET test and you don't specify any command line switches, then it's going to do an implicit .NET restore and an implicit .NET build. And you want to do these independently because you're likely going to have multiple test suites, and you want to pass in individual switches. And I'll show you the configuration in a little bit. But you see that we're passing in specific switches. Our verbosity, I always use minimal for the verbosity, because even at minimal, it puts out quite a bit of console output. If you don't go minimal, you're going to be drowning in console output. And with build, we want to have the -- no restore, and you want to parallelize as much CPU as you can. Pass in the configuration. I always like doing a full build, not an incremental. And then with .NET test, you want to pass in results directly. There's all these command line switches that you need. And so none of the templates in either Azure Pipelines or GitHub Actions are going to kind of give you all these command line switches that you need to think about. But this is how you start piecing together your integration build configuration. What I don't have in here, because there's still some support, I do not want to show you a big scripted way to do it yourself. But if you look at the Onion DevOps template in Azure Pipelines, we set up our SQL Server database for the purpose of running integration tests in the build. We need to have a version of our database, and that is not present here. So this is not a complete integration build. This is not by any means. It doesn't have static code analysis. It doesn't have SQL database creation, and it doesn't have the running of database-based integration tests. So you've got the start, and if you want to brute force it, you can do anything that you can figure out how to do command lines for. You can do with GitHub Actions, but that's not the best architectural thing to do. So if it doesn't have first class support, then I'm just going to wait and see, because it's not a good return on investment to have a whole bunch of script and then you're responsible for fixing all the bugs in that script. I want the tooling to do it for me. All right. So here are all the steps so that you can see the command line switches that I like to use when running .NET.exe. One of the things that I want to highlight is in the test run. So in TeamCity, in Azure Pipelines, in Jenkins, in Bamboo, any mature build server runs tests and then keeps track of the test results in a way that you can browse and filter and all that. And you can trend the tests over time, which ones have a habit of failing, how long they take over time. And so we push out these logger.trx files in Azure Pipelines in order for them to, for in-unit to kind of push these out. And then those are the test reports. GitHub Actions does not have a test report dashboard at this point in time. And so that's a wait and see, because any kind of integration build is going to run tons of tests, and then we need to keep track of them. So that's been a feature request for some time. I don't know the status of it, but that is one thing that would be a wait and see on an integration build is just to be able to record test runs instead of, because yes, it's helpful if your tests fail, but okay, my tests fail. Now I don't want to wade through nothing but console output in order to try to figure out and over time there's no trending. So that is a wait and see for me. Now on secret variables, if you go into the settings of your GitHub repository, you can put in secrets so that because you do not want to put in environment specific settings in your Git repository. You don't want to put in credentials of any kind into a Git repository. Those YML files, the GitHub Actions, are stored in your Git repository. So architecturally, you do not want to put secrets in those files because those go in your Git repository. Furthermore, you don't want to put anything that is specific to an environment that would preclude you from adding a new environment and deploying an existing release candidate. You don't want to do anything that would cause you to generate a new build. You want to externalize those. And so every build server, every deployment server has a first class variable management capability, and GitHub has the start of it with secrets. But I think there needs to be more to come there. This is what the console output looks like when you run the build. And this is just opening up the running of the tests. If you're familiar with Azure Pipelines, doesn't it eerily look like the console output of Azure Pipelines? So you look at it, it's like, maybe that's not a coincidence. Now, I don't have any firsthand knowledge of what exactly they're doing, but it's suspicious nonetheless, which would be a good thing, because the more they can reuse, then it's just going to make it more stable, and this is going to be able to be enhanced quicker. So this is what the output looks like whenever this particular GitHub action, the integration build, is running. Okay. Now, I want to come back and say, okay, we have our GitHub architecture. Where does GitHub fit in now? And where might it fit in the future? Now, it fits in perfectly for your Git repositories, okay? For a replacement of Azure DevOps services for your continuous integration build, that is definitely going to be a yes at some point in time. I would say today, I want to wait and see on some features, tests, database creation, environment management. I want to wait and see on those things. And then the answer will be yes. And it'll do a great job at being a first-class build server whenever they add some of those new capabilities. For package management, once the integration build stuff comes online, I think it would be a yes for package management as well. And it would be kind of, for the base scenarios, it would be on par with Azure Artifacts for storing your release candidates in GitHub package management. For deployments, I don't know yet. It's not there now. For deployments, I would still be using Azure Pipeline's Release Manager paired with Octopus Deploy. And if you give me a blank slate, if it's simple applications going straight into Azure where it's nothing but an Azure subscription with Azure PaaS services, Azure Pipeline shines and has all those in the libraries. If you have a VM-based deployment or anything complex where you have multi-tenancy or transient environments that come and go, spinning up environments on the fly, Octopus Deploy just knocks that stuff out of the park. So the bar is a little bit higher if you're going to say that GitHub Actions, you're going to use GitHub Actions only for deployment. You're going to be doing a lot of scripting yourself. So hey, it's a great new player, and definitely for open source libraries where maybe you don't have a database, but you just have a library. Man, GitHub Actions is already killing it doing integration builds and packaging for those things. People are already doing it. The success stories are out there. If you have an open source library that's going to NuGet.org, you don't need anything but GitHub Actions. It shines. It's fantastic. So, but overall, when we have complex applications, I wanted to talk about the overall architecture and where it fits and what you can do now and what's a wait and see. So maybe this is a complex environment and there's lots of things in play, but I wanted to go over that for you. All right. Let me look. I think there's questions. Some of the text was hard to read. Tell you what, I'll send me an email and I'd be happy to share, all this with you. So you have, like, I can, email you the text of the command line switches so that you don't have to type them and whatnot. Just send me an email and I can send that to you directly. All right, so to review, these are the 7 key elements of your DevOps environment. And we talked about how GitHub today will shine as your version control system and in some build scenarios, but some of the things that are missing, and then some work that it needs in order to support full system testing and then deployments. So it's definitely something that you should keep an eye on. And if you have library only applications, GitHub Actions could be your whole pipeline, because you have an integration build. You don't have any database to provision. You have unit tests for that library, and you packaging up and pushing it to NuGet. It could be your whole pipeline. But for next steps, I know a lot of you are already emailing me to get the electronic copy of my book. Get the book and read through it. Look through the public project. By the way, any of the command line switches that I showed, it's a lot of those are the same, from Azure Pipelines to GitHub Actions when you're using .NET Core. Those are in the template in the public project that's used for the book. And so if you have the book, you'll be able to get every bit of that. And so make sure to send me an email with that. So anyway, I think Gregor, I can send you that in email, your question of those command line switches. I believe I answered every other question in line. But if there's no questions that come in, the call to action is to send me an email so that I can give you the book. We watermark all the PDFs so that they don't end up on the internet. And if you're catching this recording after the fact, or if you share this with a coworker, I'll honor that offer as well. I want you to have my book because it's going to save you so much time. Just to implement your DevOps architecture and start doing builds and deployments in a completely automated way and have a shorter cycle time. So anyway, thank you so much for your time today. I really enjoy being able to share this. In the last 2 weeks, I've spoken at 2 user groups that have gone virtual. If you have connections with any .NET user groups, Agile or DevOps user groups, and you're doing some virtual events, I would be happy to speak to your group as well. Just send me an email. It's right here on the screen. And thanks everyone, and stay safe.